What if an AI could learn how to create something new? Not by being taught, but by having its very own built-in critic. Well, that's exactly what we're diving into today. We're talking about Generative Adversarial Networks, or GANs, a really cool AI system where two models are basically locked in a creative battle to achieve perfection. So let's get right into it. So think about this for a second. How does a machine actually learn to create something that feels totally original? Something convincing? It's one of the biggest questions in AI, and in this explainer, we're going to break down exactly how it's done with GANs. The secret sauce here lies in a concept that honestly sounds like it's straight out of a sci-fi movie, a battle of AIs. Yep, the whole system is built on competition, and that is precisely what makes it so incredibly powerful. So, at its core, a GAN is just a system with two neural networks locked in a duel. Generative means it creates stuff, and adversarial means it learns through conflict. You've got one network that generates and another one that critiques. You can really think of it as a constant battle of the bots. This internal competition is the engine that drives all the learning. It pushes the system to get better and better, all without a human having to step in and say, nope, that's wrong. It literally teaches itself. All right, so who are these two AIs duking it out? Let's meet the adversaries at the very heart of this creative showdown. Okay, on one side we've got the generator. Let's call it our master forger. Its only job is to create fakes that are absolutely indistinguishable from the real thing. And on the other side we have the discriminator, the expert critic. Its sole purpose is to spot those forgeries. So the forger tries to fool the critic, and the critic tries to catch the forger. It's this perfect continuous. Now, what's really fascinating here is that this is a type of unsupervised learning. All that means is that no human is sitting there, hand-holding the AI, telling it what it got right or wrong. The two networks basically supervise each other. The critic's judgment is all the training the forger ever needs. So how does this battle actually play out? You can almost picture it like one of those epic training montages in a movie where our young forger learns to become a true master. Let's see how that process actually unfolds. We'll use a pretty simple example to make this clear. Let's say our goal is to train a GAN that can generate pictures of flowers that look 100% real. Okay, so it all starts with the critic. It's trained on thousands of real flower photos, so it learns every little detail. Petals, stems, the works. Then, the forger creates its first attempt, which, let's be honest, is probably just a mess of pixels. The critic easily spots it as a fake, and here's the magic. Based on that failure, the forger adjusts its strategy and tries again and again and again, getting just a little bit better with every single round. Through thousands, sometimes millions of these cycles, the generator evolves. It goes from creating random noise to producing absolute masterpieces. You see, the whole goal here is to turn this young, impressionable AI into a master of forgery. The mechanics behind this constant improvement can actually be understood through a classic concept from game theory. It's a zero-sum game. In every single round of this battle, one network wins and one loses. There are no ties. The winner, it gets to stay the same. Its model doesn't change. But the loser is forced to update its model and learn from its mistake. Failure is literally the engine of improvement here. And this table breaks it down perfectly. If the critic correctly spots the fake, it wins, which means the forger loses and has to get better at creating fakes. But if the forger successfully fools the critic, the forger wins, and now the critic has to get better at spotting fakes. They're locked in this constant arms race, always pushing each other to get more and more sophisticated. Now, you might be thinking this tech is just for creating convincing images of cats or flowers, but that's really just the tip of the iceberg. The applications are incredibly powerful, and they're already being used out there in the real world. I mean, the range of applications is just stunning. GANs can predict the next frame in a video, which is huge for things like self-driving cars that need to anticipate what's about to happen. They can generate new synthetic data to train other AIs, which is a lifesaver when real data is hard to find. They can even create secure encryption methods and build detailed 3D models from 2D pictures. The possibilities are just massive. So here's a really tangible example for you. A GAN can take a blurry, low-resolution photo and generate a sharp, high-res version. And it's not just sharpening the image, it's intelligently creating the details that it predicts should be there. And it often does it with mind-blowing accuracy. So the big takeaway here is this. GANs learn to create by mastering the art of forgery in this relentless internal battle. But as this technology gets better and better, it raises a pretty profound question for all of us. When an AI can create a reality that's practically indistinguishable from our own, well, how do we know what to trust?